Yeah, so we'll just continue from slope form of tangent. The previous form, point form, I already discussed in the last lecture. So slope form and parametric form is left out. Now for slope form of tangent, let's say we have a circle given and we are drawing a tangent at some point, but this time the coordinates of P are not given, but you are given this line as some y equal to mx plus c. And say the circle is in short form, we'll take x square plus y square equal r square as a simple circle. So what is the first thing that I have to write here is, given that this line is a tangent, how do you write this in slope form? Slope form means it should have only m, it should not have c. So what we do here is, you can use the condition of tangency and find out c value. That is one thing that you can do. So what is the condition of tangency? Perpendicular distance from center should be equal to radius. So distance from origin to this line, mod c by root of 1 plus m square equal to radius. This is called condition of tangency. So c is plus or minus r root 1 plus m square. You can write removing the mod. So the first thing that you have to know in slope form of tangent is condition of tangency. This is called condition of tangency. The second thing is equation of tangent in slope form. For that, you just need to put the c value here in this equation. Equation of tangent in slope form. So y equal to mx plus c, you replace with the value. So c is mx plus or minus r root 1 plus m square. This is said to be equation of tangent in the slope form. And the third thing is you have to find this point of contact. So if you have to find the point of contact from the center, actually this is foot of perpendicular. Either you can find foot of perpendicular. That is one method that you can use, or you can also use an alternative method also. Like you can assume that let the point be x1, y1. And once you assume x1, y1, you already know how to write the equation in point form. You just compare that with this line. So for finding point of contact of tangent. So this third result is for finding point of contact. For that, what are we supposed to do? Let the point of contact P be x1 comma y1. Then if you know the point of contact, what is the tangent in point form? So tangent at P is therefore xx1, s1 equals 0 formula we should apply, because we already learned this before this concept. So this is same as, already you know this line. So what is the line given already? This is same as y equal to mx plus c. Or you can also write that as mx minus y plus c equal to 0. Mx minus y plus c equal to 0. Let this be 1, let this be 2. And these two equations represent the same line, and one line cannot have two different equations. So therefore, whenever two equations correspond to same line, you can compare the like terms. Ratio of x coefficients is x1 by m equal to ratio of y coefficients is y1 by minus 1. Ratio of constants is minus r square by c. And equate these two, you'll get x1 and y1. So from here, you can say x1 is minus r square m by c. This is x coordinate of point of contact. And equating this, y1 is r square by c. This is the y coordinate of point of contact. So point of contact is minus r square m by c comma r square by c. So what is the point P? Minus r square m by c comma r square by c. So we have to remember three things. One is condition of tangency. The second thing is equation of tangent in slope form. And the third result is what is the point of contact of the tangent. These three things you are supposed to remember for slope form of a tangent. And this we did for a circle with center as origin. You can also do it for other circles with a different center in the same manner. So we could have found the point of contact even with foot of perpendicular formula, but I did with a different method here. So we can also use this type of method. So I'll just summarize all this for all circles. Here, let us write down equation of circle. Here we'll write condition of tangency. Then next column we'll write equation of tangent in slope form. TGT I'll write in short form and slope form. In the last column, we'll write down the point of contact. So if you are given the circle as x square plus y square equal to r square, what is the condition of tangency we wrote? C equal to plus or minus r root 1 plus m square. Condition of tangency for, if you want to mention the line, you write down y equal to mx plus c. That would be better. And the equation of tangent in slope form is y equal to mx plus or minus r root 1 plus m square. Point of contact minus r square m by c comma r square by c. So we have found with a different method here, but we can even find foot of perpendicular. So if I am going to take the circle as x minus h whole square plus y minus k whole square equal to r square. So what is the general condition of tangency? Perpendicular distance from center equal to radius. So we just have to use that condition only here. That is, distance from hk to this line should be equal to the radius. So what will be the distance from hk to the line? Mod of mh minus k plus c by root of 1 plus m square equal to r. And you can open this and write the answer from here. So if you open that and write down the answer, I'll write it directly. The answer would be c equal to k minus mh plus or minus r root 1 plus m square. This is what you will be getting if the circle has a center hk. And this one, you just replace y with y minus k, x with x minus h. Rest of it will be the same. And for writing the point of contact from the center to the line, you can find foot of perpendicular. So I'll just mention find, I'll not write any formula, just say find foot of perpendicular from the center to y equal to mx plus c. And even if I choose the circle with center minus g minus f, the general circle, you can just write a similar result. So here the center will be minus g minus f. So k will be minus f, h will be minus g. So here it will become mg minus f because you will put h as minus g here. This minus will become plus k as minus f plus or minus r root 1 plus m square. This is the value of c. And here instead of y minus k, k will be minus f. So y plus f. M into x minus of h is minus g. So x plus g plus or minus r root 1 plus m square. And you know how to find the radius for the circle. For general form, what is the radius? Root of g square plus f square minus c, which we already know. And I'm just leaving this same because foot of perpendicular only you have to find in each case. For first one, because it is simple, we remembered. For second and third, you just find foot of perpendicular from center to the line. You already know formula for foot of perpendicular. For normal, actually, you don't need the slope form. But still, I'll just write normal and slope form. One result we'll just quickly write. So if they give you the slope of the normal, for example, this is the tangent and this is the normal. So if this is m, this is having slope capital M, you know capital M is minus 1 by m anyway. So, but I want to write the result knowing the normal slope. So assume that capital M is given. Or we can find it if small m is given using this. So if you know the center is some hk, how will you write the equation of this normal? Y minus k equal to capital M into x minus h. This is only normal in slope form. And if the center is origin, you'll take hk as 0, 0. If the center is minus g minus f, you'll take hk as minus g minus f. So this would be enough. So nothing much to explain in this topic, normal and slope form. So we'll now write parametric form of tangent and normal. This is important. So mostly in locus questions and all, we use this parametric form of tangent and normal. So if there is a circle, again, I'll just take the circle to be simple, like x square plus y square equal to r square. The derivation would be easier with center origin. Then we'll generalize for other cases. So if you are given this point on the circle in parametric form, how do you write a point? R cos theta, R sin theta. Center is origin, we know. So how to find this tangent means, already you know the formula in point form. So generally, what is the formula for tangent at P, x1, y1? You already know. We can just use that and replace coordinates with these coordinates. So tangent at P, you already know x1 plus y1 minus r square equal to 0, which is s1 equal to 0. So this got replaced with parametric coordinate. This is with Cartesian coordinates. You just replace x1, y1 with r cos theta, r sin theta. This would become x into r cos theta plus y into r sin theta minus r square equal to 0. Divide throughout by r, it will reduce to x cos theta plus y sin theta equal to r. This is the tangent in parametric form. That is at a point with a parameter theta, if you have to write a tangent, this is the formula. And if you have to write the normal, just equation of the line joining center and this point. So what is the normal at P? So normal at P, x1, y1 also we wrote earlier. At P, x1, y1, what was the formula for normal? X, y1 minus x1, y equal to 0 is what we wrote. So here we'll replace y1 with r sin theta, x1 with r cos theta. So this would give you x sin theta minus y cos theta equal to 0 is the normal and parametric form when the center of the circle is origin. So we'll generalize this for other cases. That let me write down. So if it is this circle x minus h whole square plus y minus k whole square equal to r square, for example. If I want to write the tangent at a point P, What would be point P here? H plus R cos theta, K plus R sin theta. This would be the parametric coordinates for any point on it. So the equation of tangent, just whatever you wrote earlier, you can write the same thing, but you have to replace x with x minus h, y with y minus k. So that would become just x minus h cos theta plus y minus k sin theta equal to r. When the center is hk, it reduces to this. And if it is the normal at P, so if the center is hk and P is r cos theta, r sin theta, just you have to find equation of Cp. So don't remember any formula here. Just say find equation of Cp, that would be enough. But mainly for tangent, you can remember. For normal, you can just write the equation of line joining the given point and center. You have just apply 2-point form. Same thing for general circle. If the circle is given as x square plus y square plus 2gx plus 2f5 plus c equal to 0, what would happen to this equation? The point P would be minus g plus r cos theta. So the center will be replaced with minus g minus f. So h is minus g, k is minus f. This would be the point P. And what would be the equation? X plus g cos theta plus y plus f sin theta equal to r is the equation. And for normal, same thing. The center is minus g minus f. And I think P I wrote wrong here. What was the point P in the previous case? I had to add, because there is this point. I was supposed to write h plus r cos theta, k plus r sin theta. And here, what is the center? Minus g minus f, but P is minus g plus r cos theta minus f plus r sin theta. You know both the points C and P. Then just find the equation of Cp. That would be the normal equation. Okay. So this is for normal and parametric. So after this, we'll discuss about length of tangent, then angle between pair of tangents. So for length of tangent, we know that from any external point, we can draw only 2 tangents to a circle. So from any external point P, the number of tangents you can draw to a circle is always 2. And generally, when you join the center with this A and B, we know the property that radius is perpendicular tangent. So these two are 90 degrees, and join these two. There will be congruent triangles. So that ACP triangle and BCP are congruent. So PA and PB will be actually equal. Always tangents drawn to a circle from an external point are equal. Now I want to find a formula for finding the tangent length. So suppose this P is given as some x1, y1. And circle, you can take anything. So just for easy calculation, we'll again take x square plus y square equal to r square. And name it as s equal to 0. So the purpose of writing s equal to 0 is, even if I change the circle, that result will be valid if I use the notation of s. So r is the radius, and suppose the center is origin. By Pythagoras theorem, you know, Cp square should be equal to Pa square plus r square. So Pa square is nothing but Cp square minus r square. And therefore, what is Pa square? Cp square means distance between C and P whole square, which is x1 square plus y1 square. From that, you are subtracting r square. Clearly, you know that if this is the circle S, this will be S11. So the purpose of writing this S11 is, even if I change this circle, whatever circle I consider, I'll call it as S equal to 0, and this will be always S11. So this means the length of tangent is root of S11. So whether you find PU or PB, the formula will be the same, root of S11. That is, just substitute xy as x1, y1. You put point P in that, and root of that would give you the equation. So length of tangent is root of S11. Then we'll write angle between pair of tangents. So same diagram what we have drawn earlier, I'm just repeating. So if you want to find angle between the pair of tangents, PA and PB, so join these two. If the total angle is theta, they will be congruent triangles. So each of this will be theta by 2. So if theta is the angle between tangent, these two angles are equal. Each is half of that. And this is radius. This one we just found root S11, or this also is root S11. So clearly from triangle CAP, tan theta by 2 equal to opposite by adjacent, we can write. So opposite side would be R, adjacent side is root S11. So this is the formula to find angle between tangents. If you know theta by 2, you can obviously find theta. Like what is theta from here? Theta by 2 is tan inverse R by root S11. And theta will be 2 tan inverse R by root S11. So if you want to find a formula, you can find it by writing 2 tan inverse X formula here. But generally, this would be enough. From this only you can find out. Like 2 tan inverse x, what is the formula we learned in inverse trigonometry? Tan inverse 2x by 1 minus x square. You can even write this and derive a formula for theta itself, but it would be easier to remember this. So you can prefer this itself. So then one more formula you can remember for point of intersection of tangents. For normals, it's not required because normals will always pass through center. So their intersection is the center only. Point of intersection of tangents. And this we usually require to solve the problems quickly. So this is P, this is A, this is B. Let's suppose I take the circle as x square plus y square equal to r square. And in parametric coordinates, you can write this as some r cos alpha, r sin alpha, and this as r cos beta, r sin beta. So if I have to find out the intersection point of tangent, this point P, what is the formula for that? So there is an easy way to remember. First, if I join these two, the chord equation I already explained. So equation of AB I know already. What was the formula for equation of AB? We wrote earlier x cos alpha plus beta by 2 plus y sin alpha plus beta by 2 equal to r cos alpha minus beta by 2. So from this you can easily remember P. That's why I'm using that. So P will be this right hand side you can write down. You can write down cos alpha plus beta by 2. By this term you divide here. Cos alpha minus beta by 2 of RHS you divide here without R. But R will be here in numerator. Similarly, you can write this sin alpha plus beta by 2 along with R. Divide by this cos of alpha minus beta by 2. This is the formula to remember for intersection point. But how do we get this means? You already know the formula for tangent in parametric form I just now derived. It was x cos theta plus y sin theta equal to r, but here theta is alpha. So you just have to write down the equation of this tangent in parametric form, then equation of this in parametric form, and you need to solve them to get the intersection point. I wrote that answer directly. So by solving these two lines, whatever answer you get, I wrote it here. And this can be easily remembered from here. That is, you just divide x coefficient with this constant without r and put r in numerator. This y coefficient you divide with this constant and put r in the numerator without this r. So this will be helpful when you do many locus questions actually. So you can remember it. But this is the formula only when the center is origin.
Done, sir.
Done. So then we have pair of tangents. Then chord of contact. So first we'll discuss about pair of tangents. Whenever you draw a pair of tangents again from external point, these two represent a pair of lines. So one of them is line PA is a straight line, PB is a straight line. Together you call it as a pair of lines. So if you have to find the combined equation giving this point and giving the circle. So if they give you point P and they give you some circle x square plus y square minus r square equal to 0 or any other form also would be fine. You call it as S equal to 0, then whatever formula we derive here will be applicable for other forms. Only thing, according to the S value, you have to change other things. So if you want combined equation of PA and PB, there is a formula directly S1 square equal to S into S11. There is a formula for pair of tangents. And what is S1 for this? Xx1 plus yy1 minus r square whole square equal S means the same circle itself, x square plus y square minus r square into S11 means you have directly substitute the point here, you will get x1 square plus y1 square minus r square. So you can find both the tangents combined equation with this. And if you want separate equations, you have to factorize this. But factorizing is going to take more time. So instead of this formula, when you do questions, we can have an alternative method apart from this. But this is a direct formula with which you can find. Let me tell you the alternative method also. So I'll better mention the word combined equation of pair of tangents. This is a direct formula to find the combined equation. Even if the equation changes, the formula is valid. But only thing, according to the S that you are choosing, you have to write the value of S11, S1 and all those things.